Hello, everyone. The title today is Classification of Matter. We already know what matter is. Matter is anything that has mass and occupies space. Little review of examples of matter. These are all examples of matter: copper wire, water, salt water, muddy water. Okay? They're all examples of matter, just to refresh your memory. Then, to start, let's analyze each box. Analyze each box. What are the differences between them? Remember, all matter is made up of particles. Okay, so these are particles. So what are the differences between these particles? Look at each box, pause the video, and get your answer. So I hope you got it right. You see this? Everything here is the same. Everything this one looks the same. But here, they are different. You see, two kinds of substance. You have this type, you have this type. Here you have this type, you have this type. You can easily be confused if you don't pay attention. So this and this and this, the same kind here, the same kind here. They're not the same, they're not the same. Okay, now, so from what we just said, that means this 1 and 4 contains the same kind of substance, and 2 and 3 are different kinds of substances. Contain two kinds. This one contains only one kind, okay? The same kind, the same kind. So now, that which box contains the same kind of substance 1 and 4. Which box contains only two kinds, this 2 and 3, okay? Now that takes us to what we call pure substance. So 1 and 4 are referred to as pure substances, while 2 and 3 are mixtures. If you look at the mixtures, they are not touching each other, they are not bonded, but you look at the pure substances. This one, you see that? Okay, but this one mixtures, they have two different kinds of substances. Okay, now that takes us to the definition. What is pure substance? So what is pure substance? Pure substance contains only one kind of matter. It has a constant composition, can only be changed by chemical reactions. Examples of pure substances can be iron, it can be water, it can be carbon dioxide. These are examples of pure substances. Okay? And then what is mixture? It's a physical combination of two or more substances in which each substance retains its own chemical identity. Okay, mixtures have variable composition. Let's go back to this okay, examples are salt water and air. Okay, let's go back here. Pure substance. This actually is water particle. This is water particle. Okay, so you have that the same. We cannot separate this. This is like oxygen, this is hydrogen. We can separate this by physical means. We can separate this by physical means because they are bonded. Everything here is bonded. Everything here is bonded. So we cannot separate that by physical means. But this, they're not touching each other. We can separate this by physical means. Okay, these are mixtures. Okay, mixture of mixtures. You have this one, you see, they're not the same, but they're not bonded. Okay. Now, let's focus on the pure substance. There are two types of pure substances. Elements, which is one kind or one type of atom. One kind or one type of atom, represented by two-letter symbol or a symbol. Like I'll show you periodic table later, then you see what I mean. And these elements cannot be decomposed into simpler substances by chemical or physical means. It's the smallest unit. So you cannot, no matter what you do, you still get copper. It cannot be copper and something, or gold or helium. It's just one kind of atom. Then, remember, there are two types of pure substances, elements and compound. Then compound, you have two or more different elements that are chemically combined. It can be broken down into elements through chemical means, okay? It can decompose into hydrogen gas and water gas. There's water can decompose, this means water can decompose into hydrogen gas and oxygen gas, okay? And compounds are represented by chemical formula. I don't know what I have means here. Compounds are represented by chemical formula. They have water, you have H2O, carbon dioxide, CO2. So this is compound. Anything you see something like this, there are two different things bonded together is compound, okay? So this is an example of elements, the same kind of atoms. Then these are elements. Everything in periodic table is elements. Everything. You can't find compound in the periodic table. You can't find mixture in the periodic table. Everything here is elements. You see elements. This is elements. This elements. This is compound. You see, they are different kind of atoms. If everything is the same like here, it becomes element. Okay? This is compound. So let's go back to the first thing box we analyzed, identify element, compound, and mixture. Pause the video and figure it out. Hopefully you got it right. So this is a compound. You see that? Two different elements bonded together chemically. Two is a mixture of elements and compound. Okay? The same kind of atom, that's why this is element. Then this is mixture of compound and compound. And then this is elements. Hopefully you got it right. Mixtures are not represented by chemical formula and they can be separated by physical means. This is salt water. This is muddy water. Muddy water is a mixture. So you see muddy water being like you have muddy water, mud and water, so it's being separated using filter, like you have funnel, you have filter here is catching the mud while the clean water is passing through here, being collected in LMI flask. And then salt water is also a mixture. The separation here, you're boiling it. So both of these separations that by physical means, there's no chemical means used here in the separation. So there are two main types of mixtures. Homogeneous mixture, which is also called solution. It's uniform in composition. If you look at salt water, like I put some salt in the water and bring it to the classroom, I didn't tell you, just come in and see it. You find out that you will not know there's something there. It looks the same. It may look like water, but it's a mixture, or it's also called solution. So saltwater wine is also homogeneous mixture. Soda, alloy. Alloy is where you have solution of two or more metals. They melt them and combine, mix them together. When they dry, they look uniform. So that's they are all examples of homogeneous mixture. Heterogeneous mixture, they are not uniform. You can clearly see the particles that make up the different parts of the mixture. Like if I mix iron filings and sulfur, you will see the ion filings with the sulfur. Clearly, the heterogeneous mixture, because you can see the color is different, everything is different. So they are not uniformly mixed. Then, okay, this is homogeneous mixture. Look at it here. Homogeneous mixture, you see the particle diagram showing homogeneous mixture is evenly, uniformly distributed. And then everything here, rain, wine, air, steel is example of alloy. Everything looks uniform here. Heterogeneous mixture, you see that is not evenly distributed. You see like ice in soda, you can see the ice, you can see the soda. They maintain the identity clearly. Oil and vinegar, you put oil, you will see they're not uniformly mixed. You can see the oil, you can see the vinegar. Cereal, you eat cereal, you see sometimes you have different colors, that's heterogeneous mixture. So let's watch a video.
What is a chemical compound? Let us learn what a chemical compound really is. Click on the titles listed here. Atoms, molecules, elements, and compounds. When two or more elements bond together chemically, they form a new substance with its own properties. This combination of elements is called a compound. Water is a compound made of hydrogen and oxygen. Carbon dioxide, which is what you release when you exhale, is a compound made of carbon and oxygen. Most substances around you are compounds or mixtures of compounds. All compounds are made up of molecules. A molecule is the smallest part of the compound that has all the properties of that compound. For example, a molecule of water is made up of 2 atoms of hydrogen and 1 atom of oxygen. Let's compare compounds and mixtures. Combining elements to form a compound is different from just mixing elements together. In a mixture of iron filings and sulfur, for example, each element holds on to its original properties. You can separate the mixture easily by dragging a magnet through it, attracting all the iron filings. But if you heat the mixture, a chemical reaction takes place that bonds the elements together. Not only does the new compound look different, but it also has no magnetic properties. Thus, compounds do not possess the properties of the elements which they are composed of. Separating the chemical compounds. Unlike mixtures, which are fairly easy to separate, the strong bonds in a compound can be broken only by chemical means. By using electricity, we can break the bonds holding the elements hydrogen and oxygen present in the compound water. When an electric current passes through 2 tubes full of water, it breaks the tight bonds between the hydrogen and oxygen atoms in each water molecule. Oxygen atoms bubble up to fill the blue balloon, while hydrogen atoms fill up the red balloon. There are 2 hydrogen atoms for every atom of oxygen in a water molecule H2O. Therefore, the red balloon fills up faster. Thus, when water is electrolyzed, oxygen gas is formed at the anode, while hydrogen gas is formed at the cathode. Energy changes take place when chemical compounds are broken down. Just a difference of 1 atom. The compounds displayed here may not look alike, but they are made of the same elements, iron and chlorine. The only difference between them is 1 atom. Ferrous chloride, FeCl2, has 1 atom of chlorine lesser than ferric chloride, FeCl3. The proportions of the elements present in a compound must remain constant, or else the compound changes into something else.
So let's summarize this classification of matter. We started with matter, anything that has mass and occupies space, right? So the matter is divided into two groups, pure substance and mixture. Only one substance present, like you saw in the particle diagram. The mixture, physical combination of two or more substances. Then we have mixture, homogeneous mixture or heterogeneous mixture, and the pure substance we have elements and compound. Under pure substance we have elements and compound. So with everything you've learned, classify the following as element, compound, homogeneous mixture, heterogeneous mixture. Use these letters, pause the video and use the letters to write if it's element, if it's compound, if it's homogeneous or heterogeneous mixture. Hopefully, you did a good job. Look at that. Hydrogen peroxide is a compound. You see, this is very similar to water. Water is H2O. Remember, as you saw in the video, any one atom change is a different compound because compounds have to be fixed in composition. Has to be fixed in composition. Okay, any little change, one additional atom and less additional atom, it becomes a totally different compound. And you see two different elements are chemically combined. Two different elements here. This is carbon monoxide. You see this one, carbon monoxide, carbon dioxide, but you see, they are different because compounds must have a fixed composition. You change it, it will be something different. Pizza is heterogeneous because you see pepperoni, you can see everything there. Still, it's alloy. Okay. Then salad dressing is heterogeneous. You can see everything there. Calcium is element. Rust, this is two different elements that are chemically combined. That's why it's a compound. Lead is element. Apple juice is a homogeneous mixture. Okay. Now, let's look at atoms and molecules. All matter is made up of particles called atoms. These are the smaller individual components of matter. Okay. An atom is the smallest unit of an element that still retains the element's properties. Okay. Like you go to the periodic table, you see them and they're represented by symbols. But then what is a molecule? How is it different from atom? A molecule is a combination of atoms of the same or different elements. It is a group of two or more atoms that function as a unit because the atoms are chemically bonded together. Like this, you see, these are atoms. Then these are molecules. You see molecule, it can be the same atoms bonded together, chemically combined, or different. When they're different, this becomes a compound. As long as they're the same, these are elements, but they're molecule. Okay, the same kind of atom, that's elements, but these are compounds, but all of them are molecules. All of them are molecules. Okay, let's look at the particle diagram here. This is atom of an element, molecule of an element, molecule of a compound, mixture of elements and a compound. Mixture of elements and a compound. With what you've learned, I would like you to do this. I have no answer for this because I think a lot has been discussed and you should be able to get it correct. Okay? I hope this is clear. Thank you.